Alrighty, so today we're going to talk about radians. This is particularly for any year 11s who want to just get a recap on how we define radians. Also, if you're just interested. So let's do it. So firstly, radians. Before we start talking about radians, we should talk about angles. Okay? Angles. So an angle, fundamentally, is a unit of measurement between two lines. Not distance, but more like when we take two lines from the same point, we want to measure kind of the distance between them. And we call this an angle, right? Pretty basic, nothing too crazy. Okay? But we don't care how long these lines are, right? The angle will always be the same. It didn't matter whether the line was this big or whether the line was this big. The angle is always going to be the same, assuming our lines are straight, of course. So if our lines can always be the same length, or can be any length, we may as well just make them the same length, right? So if I take a line like this, okay, and if I want to make it an angle, I'm just going to move it. Let's move it that way, right? And if we move it this way, we start to create some angles, right? We know if we move it all the way around, it's going to be 360 degrees worth, okay? But what I want us to notice is I want us to notice what this traces out as we create angles. As this line moves around in that 360 degree shape, assuming the line stays the same, we actually trace out, hopefully you can see it, a circle. Hopefully not as badly drawn a circle as that, but I hope you can see it traces out a circle, right? And if this traces out a circle, then we know we can call the line the radius, right? Every circle is defined, and we probably will write this because it's actually quite an important fact. A circle is defined by its radius. Some people will argue that the center defines a circle, but I would argue that the center is not that important if you don't care about where the circle is positioned on the Cartesian plane. If you just care about the circle in general, all you need to say is its radius. If I say, hey, I'm going to draw a circle of radius 2, and I say to another teacher, hey, you draw a circle of radius 2, we're going to end up with the same circle, right? So a circle is defined purely by its radius, okay? Defined by its radius, which is rotated around in a full revolution of 360 degrees. But now we should ask ourselves the question, where do degrees come from? Okay, we're told this from our middle school years that we measure angles in degrees, 90 degrees is a right angle, 360 degrees is a full revolution, and so on and so on and so on. There's good reason for that. 360 is a nice number, and it's easy for our brains to comprehend, and so it just becomes comfortable. But actually, 360 degrees, it's arbitrary. That is, there's not actually a reason for it other than the fact that someone just decided it. Now, if you're interested, that someone was actually the Babylonians a while ago. It's because they worked in base 60, and 360 in base 60 is just kind of a nice number. It's also nicely divisible by lots of things. So their calendar also worked in 360 days because they knew it took roughly about that to orbit the sun. Some historical facts. But all that aside, degrees actually, whilst they're nice in the sense of we're comfortable with them, they're not actually related to the circle in any way. We kind of just impose them. So what would be really nice is it would be really nice if we came up with a unit of angle measurement that was fundamentally part of a circle, okay? But we know that a circle is purely defined by its radius, which means it would be really nice if we came up with an angle of measurement or a unit of measurement for an angle that related to that. How are we going to do that? Well, we'll see. So firstly, let me try to draw a nice circle. So we'll put the center here. I'm going to label this radians because that's what it's going to be. Let's draw a circle of roughly about this radius. Make it a bit bigger. let's do this. So could be worse, could be better. We'll take that. We have a circle. Its radius, let's label it R. Okay? And what we're going to do is we are going to rotate this radius from the horizontal. We're going to rotate it this way until we get to a certain point. Now, what would that certain point be? I'm actually going to draw it a bit better because otherwise you might get a bit confused. We're going to draw it to about here. And what we're going to say is that 1 radian, and we label a radian with C, okay? 1 radian is defined to be the unit of measurement such that the arc length that we have created is also exactly 1 radius worth. Let that sink in for a second. We move the angle, or we create the angle such that we get a length of the radius around the circumference. Yes, it's curved, but we're allowed to do that. But we make it so it's that. Now, why would we do that? Well, firstly, I guess it just means now we're measuring our angle with some sort of relevance to this 1 radian is the exact angle that we need so that we've traveled 1 radius length. Cool. So what? Well, the reason is because now we actually get to relate it to the very natural geometry of a circle. Our radians are effectively tracing out the circumference. What is the circumference? Well, we know that the circumference is equal to 2 pi r, right? We know it's equal to 2 pi r, which means we can actually derive a really important idea from radians. This is almost the reason why they were created. That is, if there are exactly 2 pi r, or the circumference is exactly 2 pi r, that's another way of saying that there are exactly 2 pi radiuses, or radii, right? Hello, Percy, that's my cat. So, how does this relate to radians? Well, we can think, if I kept this going and I kept measuring this angle, we know that a full rotation is 360 degrees, but we want to measure it in radians. We know that every single radian gives us a radius length. 1 radian equals 1 radius length, which means how many radians give a full revolution? Well, that's the same thing as asking how many radiuses are there in a circumference. And that's exactly 2 pi. Wow. There are exactly 2 pi radians in a revolution, because it takes you exactly 2 pi's worth of radians to traverse the circumference. 1 radian equals 1 radius. So 2 pi radians equals 2 pi radiuses, which gives us the circumference. How awesome is that? I think it's pretty awesome. So we've defined a new unit of measurement. We need to remember this. I'll write it over here. Radians are a unit of angle measurement, in the same way that degrees are, except we don't use them to measure water or milk. Okay? So the natural question that we should ask ourselves is, well, now that we know that there are 2 pi radians in a full revolution, we can actually start to think about conversions. I should say, the reason why radians are really helpful is, one, they're related to the natural geometry of the circle, as I said before. That is, the radian definition means that we measure 1 angle's worth of radian by the radius, which is the only thing we need to divide to define the circle. The other important thing is that it also gives us exact values. Note that 2 pi is an exact value, so when we split it up, it's going to give us other really nice exact values. And we're not going to get into decimals as quickly. Conversions. We can work this out pretty straightforwardly. We know that there are exactly 2 pi radians, okay, put a bracket around it so we don't get confused, in 360 degrees worth. I put those things in brackets because you need to recognize that they're just numbers, right? 2 pi is a number, 360 is a number. The way, what they're measuring is different, but they're still numbers. So we can say, we can split this into 2 cases. We can divide both sides, and we can say 1 radian is equal to 360 over 2 pi degrees, which tells us 1 radian is equal to 180 over pi degrees. Okay? Which is pretty cool. Which means basically this tells us that if you want to go from radians to degrees, you need to multiply by 180 over pi. Okay? If I had 45 radians, I would just multiply the whole thing by 45, right? But that direction isn't that common because we start off with degrees and we go to radians. So usually we do it the other way and we say 2 pi divided by 360 radians is equal to 1 degree, which means that pi over 180 radians is equal to 1 degree. And what that tells us, probably more importantly, is that when we want to go from degrees to radians, we need to multiply by pi on 180. Okay? Super, super, super important. Great. Now, those conversions are going to be helpful, but we also can just kind of vibe them a little bit. We don't need to use this conversion formula all the time. So we're going to label these common conversions. Okay, common conversions. We know that, let's just make this table. We'll go with degrees first because that's what's more familiar. And we can just fill this in and we can just do a bit of division as we go. 360 degrees is 2 pi radians. That's what we figured out above, which means that 180 is pi radians divided by 2. 90 is pi on 2. 60 is, we can look at 180 divided by 3, so pi on 3. 45, we can look at 90 and divide by 2, so pi on 4. And 30, which is, well, you can work it out from multiple ones, but I'm just going to say it's pi on 6. Cool. Apologies for those uneven lines. This is really important. You can see how pi is coming up everywhere, which is really nice because pi is naturally related to the geometry of a circle. And it's really nice that we're measuring our angle in terms of that. We're going to see how that gets better later. But for now, that's how we define radians. Super important in mathematics. Trig basically doesn't function without them after year 10. So enjoy. Have fun.